So I've just gone, to add the third element, the element concerning food, excuse me, yes. There's actually 4 total elements of this model. The first was the GIS, the second was the food procurement, which we've just added here with the state chart. The third component will be food consumption behavior, and for this we've gone to the action chart of the palette here. And again, if you can't find it, you can get it through this plus. And you'll notice that we have the opportunity to place into the model some constructs which are which allow us to describe recipes or algorithms or decision rules in this case for choosing. And these things can always be written as code. So if anyone here is familiar with Java or very comfortable with programming, there's no need to use this. But for models that are visually, well, I should say there's no need to use it for your sake, but to build models that are visually transparent, that are clear to stakeholders, that you can show to someone from any background, they'll understand the decision rules that you're capturing in the model. This is key, to visually characterize the sort of rules associated with the model, okay? So we're going to make use of this, and it's going to add a bit of time, but I believe it'll more than compensate for it in terms of clarity. So, before we eat lunch, we will construct an action chart. So, steel yourselves, and we're going to now engage in building up this action chart. Okay. Okay. So, here we go. And oh yeah, we'll need to make then two decisions, or two small changes to that food procurement state chart, not just one. Okay, so ladies and gentlemen, in order to build this action chart, I would like to add in two variables that we're going to use in this action chart. Okay, we're going to add them into person. Where do variables live? Does anyone remember? They live in the agent element of the palette. So we're going to go to person. We're adding these in, ladies and gentlemen, to person. And we're going to drag in variable here, first variable. And this variable is going to be called count supermarket meals remaining. Okay? Okay.
Nate,
Yes.
question for you.
Yes.
Can you briefly describe the difference between a variable and a parameter?
Happy to do so. Thank you. There's a natural confusion because both hold values. Both can be used to help guide execution. Why would you use a variable as opposed to a, under what conditions, what's the natural realm of application of variables compared to parameters? Parameters serve basically two functions in life. Number one, they encode an assumption. So typically associate them with sort of a property that is changing very little, often, I would say typically not at all. You can actually assign to a variable, to a parameter, but generally speaking, they represent characteristics, assumptions about something that are more or less fixed, okay? Now, they encode that assumption, but they also communicate the value from the point of creation to the agent. So let's consider home here. Home associates each person with a home that's not changing. They have some home. They have a home associated, and they have some preference for convenience or meals, right? Now, the values, the assumptions to use for those are specified when people get created. And in this model, and we'll see a difference from this in later models. In this model, where that is up here in the population. So the homes were specified here, and the preferences here. So the parameter serves to encode that assumption, in this case at the person level, could be at the main level, and to communicate it. If we have a parameter in main, such as population size, that is specified in the thing that creates main, which is the experiment. If we have a parameter in a person, like home, or the preference, that is specified in the thing that creates person, which in this case, for our model, is just the population. So parameter serves the function of encoding an assumption, typically varies little, and it communicates that assumption further from the point of creation to the thing being created. Okay, that's a parameter. By contrast, a variable has a much more sort of simple and focused job in life. A parameter, ladies and gentlemen, keeps track of some quantity that's typically changing. Now, we will actually see in some example a parameter a variable that's fixed, but we'll that's an exception, and we'll show how to indicate that very specifically. It's a special subtype of variable that just encodes some constant assumption. But here, for the most part, variables exist to keep track of quantities that are changing in the model. They're not an assumption that's fixed, and they're not communicating something from the point of creation to the agent, what to assume about itself, about parameter size for main, or about the home for the person. Rather, a variable just encodes, right now, what's the value of it? Take color, or take this count of meals remaining, supermarket meals remaining. That will be changing over the course of the model. And often variables are used for that. They're kind of utilitarian things you have for the implementation to keep track of some information that's changing over time, rather than encoding an assumption, a property of the person that has weight to it, and that is used as sort of an important assumption about the person, important characteristic. So these variables often serve very utilitarian roles. Are those comments helpful?
Yeah, that's good.
Okay, glad they were helpful. There's some other slight differences too. It turns out that there's slightly different times at which they're initialized with a variable. With a parameter, you specify a default value for the parameter that you can specify, but it's actually, this is just, if no one specifies sort of what to assume about this, it'll be using this little thing to determine what to assume. The fact that I said this means over in main for population, it used that. But I could always override this. I could always say, well, no, in my case, I want to derive from a beta distribution with, parameters X, Y, Z, or whatever, and it would use that accordingly. Or I want to draw it from a truncated normal between these values. And that would be fine. So parameters have kind of defaults that are used to kind of, if nothing's specified for them, use this rule to assign it. By contrast, variables have initial values because their job in life is to change. So this variable, count supermarket meals, it's going to be an integer. Mark my words. It's going to be an integer, and its initial value will be 0. And it'll be changing over time. Generally, we don't have that with parameters because parameters are given one value and they stick with it. So you don't have some initial value. That's not something I tell for the parameter in person. The person who tells the value to assume for this parameter is the thing that creates person. So I'm not giving it an initial value in person. That's not the business of person. That's the business of the thing that creates a given person, in this case, population. That's helpful? Okay, great. Thank you. Okay, so ladies and gentlemen, I was adding 2 parameters. One, count supermarket meals remaining, and that's an integer with initial value of 0. And the other is going to be called very similar. And so similar that I'm going to push Control, click on this, drag down, and it will create a copy of it. And I'm going to call it count. Anyone want to guess? Convenience store. Convenience Convene. This is terrible. Convenience. Convenience. Convenience store meals remaining. Okay. Okay. Count convenience store meals remaining. Okay. And it's an int, and it also has 0 initial. Actually, the initial values of these, excuse me, count supermarket meals remaining, initial will be 9. Count convenience stores remaining will be 6. Okay? 6 meals remaining. Okay, great. So we'll have a larder initially of 9 supermarket meals and 6 convenience store meals. Are we okay with that? Okay. Often in models, that initial state gets quickly forgotten. Okay. Okay, so now we're going to dive in. With those in hand, we're now going to dive into things. So I would like, ladies and gentlemen, to add an event. This event is going to periodically cause someone to eat a meal. That's the job of events in life. It's to periodically, it's a schedule, excuse me, it defines an event schedule. So we're going to go to the palette, to the agent element of the palette, and we're going to drag in an event, and this will be called eat meal event. And this will be set at a rate, the trigger type rate of 3 per day. Are we okay with that? We okay with that? Okay, ladies and gentlemen. Eat meal event. Okay, now. Okay. So, next. Okay, so my tablet is exhibiting considerable pathologies. Okay, so next we're going to add in a state chart, which is going to go and basically describe how to eat, sort of the basic mechanism for eating a meal. Okay.
Nate,
Yes.
before we get into that, because that's its own little logical chunk, looks like food got here a little early.
Oh, it got here early.
It's hot, ready to go. We just got to bring it up. So this might actually be a really good spot just to break.
I agree with that. Okay, so we'll do that. Okay.
Okay.
Great.
It'll come up here in just a little bit. In the meantime.
Are people ready to eat?
Yeah.
Okay. Good. Great. Yes.
Just take this opportunity, a more general question.
Sure.
In terms of, obviously we're using this graphical interface to build different components of
Yeah.
the model. Can everything that we've been done be basically imported in terms of, whether it be like effectively CSV files or whatever, if they're in the right format? Can you import it and then would it create and populate kind of the graphical representations?
That's a very good question. That's a very good question. And the answer is yes and no. Okay? And I'll try to delineate what I mean by each. So there is a textual description which is used by AnyLogic for everything we've done. Everything that we have done has a characterization which uses only text to describe it, and it is possible to use to good effect sometimes the fact that there's a textual representation, for example, to compare what changed between two versions of the model. Okay, so you can actually do what's called a diff to sort of tell, okay, what changed between these versions of the model. You can search in that textual representation to find things, etc. So that textual representation, it's not a CSV file, but it's another file that, like CSV files, is extraordinarily widespread, and it's what's called an XML file, extensible markup language. Okay, that's how any logic models are encoded. They're not a binary thing where you can't tell what's in there. They're actually in text in this markup language, which is kind of a generalization of what you see in HTML. For any of you who are familiar with that, it's different from HTML in the sense that it's not designed to describe the appearance of web pages, but it's like it in the sense that it's a tag-based language. Okay. So in that sense, yes, you can have that. Yes, it's just a text file. Yes, you could store it away. Yes, you can compare it. It requires a measure of intestinal fortitude to go through it. It's more than intestinal. May I show you?
Yeah, great.
Okay. Before I show you this, let me show you another thing which relates to this, okay, just because it will be right in the interface. If you go to Tools, there's actually a tool here, and we have to go select the model. Go select the model here. There's a tool called Create Documentation, which will actually create documentation for your model for different elements of your model. You can tell it what to include here, and it will actually go create a PDF document or a Word document or what have you that characterizes systematically what's in the model, which is related to your question, sort of having a thoroughgoing characterization. So instead of going into here and finding that and going here and clicking and going here and seeing what the assumption is, it's going through and systematically describing what's in the model, what the settings are, and all those sort of things. So that's a little bit related, but let me show you the encoding of the models. If you're willing, let me illustrate both its positive and its positive sides and its room for growth. Okay, so here. We will go and we will find a place where there are a certain number of models encoded. Okay, so example models, and here are the AnyLogic 7 examples. Okay, so I have some examples here, and I will open up a model that's related to this, right? So I think there's a GIS food environment, food and physical activity environment. I'm going to open this up for you. And I'm going to open it up with, okay, open with just the default thing. Oh man, okay, yeah, sure. Select this. Sure, open it with Notepad. Sure, come on, I should have Notepad. Oh man, don't want to look at that. Sorry, this is not formatting it nicely. Let me open it with something else instead. Do I have Notepad++ installed here?
It looks nice, Notepad++.
Yeah. Unfortunately, I don't have it on this virtual machine, but I do have, I think, WordPad. So let me see if this makes it look any nicer. Yeah, I have Eclipse. Oh, of course. Yeah, of course. Let me just open in my Linux. Well, if I open in my Linux, people on the web can't see this. So mumble. Let me just go try opening it here. Sorry for the delay here. I had to reinstall on this virtual machine. Okay. Here we are. Something like that, right? Here you can see it's actually encoding things, and you can go see, certain things are manifest here, right? Here's the day being declared as the model time unit, right? Here's the name of the model. Here's the version of AnyLogic that was used to create the model. Now, this particular one I have been known to work with. because AnyLogic, to its great detriment, is extraordinarily finicky about the model version you use to create the model. So if you create a model with version, I don't know, 7.1.2, it often won't allow it to be open at 7.1.0 or something. And so sometimes I have my students who have 7.2, I have 7.1.2, they modify a tiny thing in the model, and suddenly I can't open it, and I go here and I change it to 7.1.2, and it's a happy camper. But in general, you know, here, all the information in the model is encoded here, and there are viewers that will view this in a much nicer form, an XML file. There's specialized XML viewers that I have on a different virtual machine that do really nice views of this, allow you to expand different areas of it. You can zoom in, but it's verbose, and it's not very pleasant to look at, but it does have all the information in it on things. I mean, here's some GIS related information. Probably some of these names like Footscray and Alexandra and Westgate, these are probably familiar to people who live in the Melbourne area, but they presumably relate to things in this area. Here's my code, right? Here's some code that we're going to be building up after lunch. And all this stuff is in the model. And I can do a diff. I can compare one version with another and say, oh, just these 3 lines of code changed. And that's very useful. But this is not the sort of thing which I am going to go and modify typically. I typically modify this about, I don't know, twice a year or something. I'll occasionally go, and just for convenience, I'll go change something here, change the version often, etc. Notice that here are the various outlets. This is the Coles outlet that we had in our here's Coles 4. These are various food outlets that we had in this particular model. So is this helpful for your comments?
It is, yeah. I suppose in terms of getting things like, you know, tables of the parameter values and that, is that basically the documentation is the nearest to be able to do that? Or I'm basically thinking if you wanted to kind of do it in another platform, for example, you want to output a model and then redo it somewhere else.
So if you want to output it from AnyLogic, you want to put it, if it's a pure agent-based model or one with small bits of system dynamics, maybe you could export it to Repass or something like that. Yeah, I mean, the documentation is, you know, one asset there. Generally, I maintain, you know, for many models, we'll maintain some metadata about the assumptions about parameters which we're using separately for the sake of writing papers and so on. And, you know, sometimes there'll be external files that are used to derive the parameter values, and those parameter values are read from those files. If we have time and based on priorities, we'll see how that's done, but you can read from a database or read from an Excel file, you know, what to assume for certain parameters or certain variables, and so we'll have that as recourse. I will tell you that I don't believe that the current state of documentation is fully adequate, that AnyLogic automatically documents, and I am keenly aware of one of AnyLogic's, I think, foremost shortcomings, of which there are a number, quite a few at one point or another, but one of its biggest shortcomings is that you have to kind of learn where to look for things, like where to go for certain things. You know, like there are some things you have to go to main and go and find the state of the, you know, go and find where the network is specified in main, or where the space setup. In other cases, you know, I have to know, okay, I should go look, for example, in the characteristics of the particular population to find things, etc. I guess this is where the space and network is specified for GIS type models or what have you. But in any case, this is a shortcoming that you have to kind of poke around. Documentation does put it all in front of you, and you can be quite specific about what goes in the documentation and what does not. So if you don't want information about presentation going in there, you can omit that sort of stuff. But it's still a far cry from what would be fully useful. And Jeff and I have both, on more than one occasion, been poking about any logic, come on, we can do better than that. And they'll readily say, yeah, I know it's not good right now, and we need to do that. But
That's great, that's very helpful.
very good, thanks. Okay, any other questions before we dig into the hot lunch there? Okay, should we go eat? Okay, great, great. And we will resume this model building with the eating meal after we eat our meal. Okay? So you can study your own behavior and...
Map there, you've got several million people living in Melbourne.
Right. Yeah.
What do you do to manage? Because obviously you don't want like 4 million dots representing people.
That's right. Okay, so thank you for that question. Is it Matthew?
Yeah.
Yeah. So thank you for that question, Matthew. The question, as I understood it, was a question concerning scaling. Right now we have an extraordinarily small number of people, and we've done that to make it very interactive, be able to run it with very little time. But if we had many more people, we were concerned with how could it scale to handle that. How would we handle that? Okay, so there's two different phenomena that we have to deal with there. One of the phenomena is that in a GIS model in particular, there's a lot of routing that's done up front. And once that routing is done, as I know, from then on it tends to be quite fast. It's just trying to figure out the requisite routes from each house where a person lives to the nearest convenience store or grocery store. Once it figures those things out, which occurs very, very quickly, it will then be able to run the rest of the model quite quickly. So there's going to be a much larger initial hit with the larger population, right? I can't speak for Dylan, but I know with some GIS models that I've run in the past, if it's a larger population, I'll just set it running for an hour and it will figure out all the routing, and from then on it'll be quite quick. Now, the deeper question though, or the more sustained, abiding question is concerns scalability in general of these models. And this is an area where there's real differences between the different techniques. And broadly, the division is not, is cleaves along the lines of aggregate models and individual-based models. Aggregate models, like that system dynamics model that we saw on Tuesday, the one that characterized sort of the requisite population into stocks, into sort of accumulations. Those models run at a speed invariant to population size. So it doesn't care whether it's 10 people, 100 people, 1,000 people, 10 million people, 10 billion people. It's just the number of people in a given state is a number. And it doesn't matter if it's a small number or a big number, it computes things equally quickly on a computer. Okay? So with aggregate models, things execute very quickly and invariant of size. By contrast, they tend to scale very poorly with heterogeneity. They have adverse scaling. They become geometrically slower as you take into account progressive levels of heterogeneity. By contrast, individual-based models have the opposite relation. They become a lot slower as you raise the population size. As you double the population size with today's typical technologies, running this on your desktop, you're going to approximately if you double the population size, double the running time, okay? Or worse, because you have interactions. By contrast, in terms of heterogeneity, adding heterogeneity makes very little material differences to the cost of it. What this does mean is that in individual-based models, and I put there most agent-based models, and discrete event models, there's a great deal of caution that needs to be undertaken with respect to large populations. And generally, we distinguish between running a model for exploratory use and running it for what I call production use. So for exploratory use, we often do so with a small population. For production use, let's say for paper, results to present at a conference, for policy recommendations, we'll often run the model with a much larger population. So we'll go between these contexts of running with small populations and large populations. Now, it turns out that there's care that has to be taken there, because if you change the population size, your intention may be to change only the population size, but you have to be careful you haven't also affected other things which really matter for model mechanics, like the density of the population, the number of people, the waiting time people experience, because there's fewer people, demanding access to the clinic. So if you're not careful, lowering the population size changes the dynamics in a big way. So when you change the population size, let's suppose you have people presenting to a clinic, right, as part of the model. You're going to want to similarly scale. If you make the population size 1/2 its normal value or a quarter, you're going to want to make the number of clinics or clinicians in the clinics comparably lower. And there's a whole balancing there. And I have a paper on this if you were interested. But by and large, we run with scale models. Just as engineers have traditionally built scale models of planes before actually building the full thing, we operate with scale models with individual based things. And then, when we need them for production use, we'll throw a big iron at them, or we will run them for a longer period. And AnyLogic, like some other modeling platforms, is increasingly seeking to tap into distributed computing resources. One of their next big pushes is towards the cloud, which would be running these simulations not on your machines, but out there in the ether on machines where it can scale to large number of runs at the same time, which will be important, particularly when calibrating performance parameter variation experiments or developing recommendations that are robust under stochastics. So in short, population size makes a big difference. You want to be artful in your population size. How big does AnyLogic's population scaling go? What sort of scales at which you can run things? Well, this is a very important issue. So I've used NetLogo and worked on projects where NetLogo was used for a while, and then a switch was made to other platforms. NetLogo is a very nice platform for certain basic uses for agent-based modeling, but it exhibits real issues with scaling. AnyLogic is much better than NetLogo, but once you get into the realm of hundreds of thousands of agents, your model's definitely running quite a bit slower. We have a model that we run for production use right now for pertussis. This is for Alberta Health Services, which is very aimed at really materially impacting their understanding of the impact of outbreak response interventions. And that is about 750,000 people in it. And then we run it quite frequently with that. It's not something we prepare for weeks to run it and do a single run. No, we run it quite a lot with that, 750K. But that took some effort to sort of prevent certain bottlenecks from bogging us down. And the biggest one in that case was the fact that with AnyLogic 7, the network performance is pretty slow with AnyLogic. And I don't know why. It used to be faster, but now it is quite a bit slower to sort of hitch people up to the networks. It wasn't a big deal for us to work around that. We have rich networks in this model, but it's what we accomplish it in a different way that didn't require a lot of effort. But AnyLogic gets slower, and for GIS type of stuff, AnyLogic is going to get really quite a bit slower because of the amount of GIS data. Generally speaking, I'm very comfortable in the tens of thousands of areas for sort of routine use. Hundreds of thousands, you probably want someone who can work with you from computational background to sort of help help study what is taking long enough in your model and fix that problem. So, and you can systematically remove these bottlenecks, okay, in the model. And there are tools called profilers, which will help you study your model behavior and try to zero in on what's causing the adverse performance. This is one of the advantages of any logic being smack dab in sort of the midst of a Java ecosystem. There's tons and tons and tons of tools that are available that can help you do better modeling at one level or another. And one of them is something called profiler. Others are database connections, or others are tools to help you debug your program or whatever. Dylan.
Actually, I have a question on the subject of the networks and scalability.
Yep.
So, this is something I've only really had to think about recently, given the model that I'm working on. I find that I can put hundreds of thousands of agents of particular kinds into a model, and that doesn't adversely impact performance. But certain agents that I have, that have network links, like agent link collections, those ones seem to be very slow for some reason.
Right.
Is that just a consequence of having different networks in an agent? Like you said, it used to be faster than it is.
It did.
Is it like SD, like the second you drag in one of those components, it drags things down? Because if so, I'm going to change the way some of my stuff is working.
In short, yes, that's my observation. So the addition of connections, this took me by surprise. This is something I've discovered in the past 6 months. But adding network connections is really slow.
I don't mean just adding them. I mean...
No, I understand you don't mean adding them, but it requires adding them.
Yeah. And so once you do, then it's slow
yes.
down. So, oh, geez. Okay, so...
Now, it also is an issue, computing certain networks. For some reason, it's really slow, computing scale-free network topology and so on. But that's a secondary issue, because it's often this one of just adding connections that bites you. Talk with Winchell about it. He's the man.
Okay.
Yeah.
Yeah. So that's one of the reasons that I wasn't sure about it, but I had some suspicion.
Yeah.
But that's one of the few things that won't show up in a lot of free compilers because it's hidden in AnyLogic's stuff. So I can never investigate, but knowing that actually is a problem for really big populations, like that would be a significant slowdown, is very useful to know. So.
Yeah. And we're talking big populations, like hundreds of thousands,
yeah.
right? Yeah. Yeah. Let me just state it bluntly. It's a dog. The capital D. And maybe they'll fix it. For all I know, maybe in 7.2 it's fixed already. I don't think so, because I think Winchell's using it. But maybe 7.3 will fix it. They just got to fix it. I think they did something between 6.9 and 7 where they thought they were being clever, and maybe they sped it up in certain cases, or maybe they just had to re-implement it and they didn't do it, with enough scalability care. AnyLogic tells me that they've run this model on up to 3 million agents. It used to be said, but that was with version 6, and I think 7 may have a somewhat different profile. But they've done a couple million agents, and I can believe that. I've done 1 million agents before. What you have to watch out for, you have to do it more carefully. Now, I have a whole set of lecture slides I've given you on performance with AnyLogic. And the other thing you got to watch out for is visualization. Fortunately, I'll show you a trick that you can use to have rich visualization of the model, but still run it really fast without visualization. Yeah.
You're saying before that when you have a GIS model, it'll
Yeah.
run slowly to begin with while it sorts out the routes and then run quicker.
That's right.
Is it possible to run it to a certain point and save that and
Yeah.
then do experiments without changing the routing?
Yes. So this is something Dylan mentioned earlier, right? And Dylan can speak with more authority on this issue. But the basic deal is that, in fact, I think you might even see it here. You notice there's this thing in this called a cache. Okay, and this is located. This is the actual model file, and it's actually created this thing called a cache. Now, a cache in computer science terms is used to refer to a situation where we compute some values or we go through work to get them, and then we sort of store them away for easy reuse and quick reuse later. It's an easy, quick place to just go get needs addressed rather than having to re-get them again or recompute them again. So AnyLogic can actually create computer copies on your computer of things that it needs to do to get the model going quickly. And Dylan, do you want to comment? I think you said earlier that there's a way to tell it or request it to sort of keep certain information related to routes or something on your computer. Or you said something like you can tell it to do it so it's just saved on your computer. I know.
Oh yeah.
Yeah.
So there are various services out there, and AnyLogic in their help files lists a couple of them where you can say, I want this particular province or this continent or this region of the world or this town, and it will download from that particular service the most detailed map of the area that they have. And basically it sits, AnyLogic then just constructs the cache from that. So then it can rip out those values whenever it needs them, and it runs a lot faster. So rather than having to, let's say, go off to AnyLogic server, compute it there, and come back from their stored copy of it, you just have your stored copy sitting right beside the model.
Right.
And yeah, if you go into the help files related to the GIS stuff, they list a few websites where you can get it from.
Okay, thanks very much. And probably I should again feature just a little bit this AnyLogic help. Their help system needs some help. It ain't one for the record books. In fact, I don't think it's made a lot of progress in terms of its general function for about the past 6 years or something. But it does its job. It's okay, and I refer to it some, and there's a lot of useful information here. But as Dylan said, there's information on, for example, GIS models, and you can save these things as well. And somewhere in here, I guess there's there's information on sort of caching or sort of saving away information. Okay, so I don't know. GIL, here it is. Yeah, finding locations and defining routes, and it can provide you. So here it is. To make it easier to develop and run your model, performance as routes will be cached in the model's folders. To obtain the necessary routes from an online map service and then cache them as GIS routes, follow the instructions below. And here they give some information about how to do that. And this can help improve your performance. So thank you, Dylan. Okay. So are we ready to push this forward? Ready to move on that second big component of making food choices after you have a larder of food to make choices about what you're going to eat? Okay, so let's put that into place. Okay. Now, I'm currently experiencing adaptive thermogenesis for my lunch, so I'm going to take off my sweater and cool off a bit. Okay, so ladies and gentlemen, I am going to here. We went back. Do you remember we added this event? This event was a eat meal event, and it fired off 3 times per day at a certain rate. And what that rate means, again, it's a hazard rate. 3 per day just means there's an average of 1/3 of a day between times when you eat. It's a fixed probability per unit time, not a probability, but a probability per unit time of eating. Okay, but we have to say, if you're going to eat, what are you going to choose? Maybe you have multiple elements of food ladies and gentlemen, in your larder. Okay, so to give ourselves some room here, I'm trying to minimize our difficulties. And ladies and gentlemen, I would like to propose to go down beneath this state chart. And we're going to put some decision-making representation below that state chart. Okay? Here you go. Okay, so below the state chart, we're going to put in place an action chart. No less, ladies and gentlemen. Okay, so here we go. We're going to go over to the action chart library. And we're going to draw in here an action chart, which is going to be called Eat Meal. Okay? I'm going to draw it over here to give ourselves some room on both sides. The action is going to be called Eat Meal. Okay? Eat Meal. Great. Now, when we add this action, it's got some mechanisms here, and we're going to successively place items into this. And there's a little bit of art to this and a little bit of finickiness to this. So we're going to need to be careful, and the TAs will help you out here, okay? Okay, because this could get a little bit finicky, okay? Okay, so we're going to put in a decision here. We're going to drag it over, and you notice I'm dragging it to this point here where it's becoming green, okay? And I'd like you to say okay, and it will add this choice here, and this choice is going to indicate, okay, do I it's one of two outcomes, true or false. So we're going to put in place two things. For each item we add, we're going to give it a nice name, and we're going to give it some logic that's unambiguous logic as to what it will do. Okay? So these are going to be two different things. The name of this decision is going to be do I have oops, okay, sorry. The name is going to be determine if, or I'll call it, sorry, are both food types available? Okay? Any logic will not allow you to do question marks, unlike Lisp. Okay. Okay, the label for this will be, do we have both convenience and supermarket meals available? Question mark. Now, you notice when you give those, it will actually indicate these things. And I'm going to pull it sort of both ways, so it'll actually all lead it. Do we have both convenience and supermarket meals available? Okay. Now we've done the basics. The name of it was, are both food types available? The condition here, by contrast, is going to be something that depends on these variables here. And I'm going to give you the syntax here, and I'm going to ask, ladies and gentlemen, nay, I'm going to beg your pardon. Okay? So basically, could anyone give you, if these count the number of meals that remain in my larder, 0, 1, 2, 3, under what condition will I have both meals available?
They're both greater than 0.
Sorry?
Both counts are greater than 0.
Both counts are greater than 0, precisely so. Precisely so. So, the job is to translate that into something that Java understands. So, one of them won't be anything problematic. Let's start with supermarkets. Count supermarket the condition will be greater than 0, if that's all we had, right? So that's all we concerned about. So we need to say, is this true, and is the count of convenience store meals remaining greater than 0? And in order to say and to Java, it's just an ugly fact. You have to say ampersand, ampersand. That's how you say and. It's a little bit, you know, a single ampersand serves as sort of and in English, but but here we need and. So I'm going to put this up, ladies and gentlemen, on the big screen. Okay, and I'll just so you can see both sides of it. I'm going to put it onto 2 lines, but I'm putting it all on 1 line in any ledger. Okay, so is this true that we have supermarket meals remaining? In other words, is it greater than 0? And we have convenience stores remaining. Is that true? That's what it's going to determine. And in one case, it's going to flow to the true side, and otherwise to the false side. Are people okay with that? Remember, please, control space, autocomplete, whatever it is in the Mac, that's your friend. It'll be a trusty friend. And like a good friend, it will tell you if something's wrong by not being able to do its job. Okay? It'll let you know. And if you're in that situation, summon a TA. Okay? Are you ready? Okay, who would like a little bit more time? Are we ready to go forward? Okay, great. We're cooking with gas. This is great. That was one piece of this, and that was actually a substantial piece. Okay? That was one of the more confusing things. Okay, so if both are true, then we are going to do something. We are going to flip a coin, ladies and gentlemen. Flip a weighted coin according to preference. Okay? So, to flip a coin, what sort of thing do you think we'll drag in? If we have to flip a coin and make one decision one way, the other decision the other way. It's a decision again. So we drag it, and notice this has to turn green. Make sure this is turning green as I drag it over there. Ready? There we go. Okay. Ladies and gentlemen, let us select that item, decision. The name of the decision will be choose meal according to preferences. I don't like that name, but I can't think of that much of a better name. Okay. The condition here is going to be based on our preferences. Unfortunately, does anyone remember where we have our preferences stored with respect to meals? Remember this is preference here? Do you remember that? So, what we'll put in place here is, for the condition, anyone remember how to flip a coin with a certain probability it'll be true, otherwise false? What's the name? Random true. Oops, not that. Random true with the probability preference preference for convenience store meals. Okay. So the name was choose meal according to preferences. The condition was there. Now we need to give it a nice name, and so maybe I'll say we could say flip a coin according to preference. What do you think? Or we could say choose meal according to preference. What would you prefer? Choose meal according to preference. Okay, good. And now let's make that similarly. Now, I use the name choose meal according to preference, but you know, it's actually not a great name because it doesn't indicate what true means. Okay, so you have true. How is that different from false? Is true mean you eat a supermarket meal, or does you eat a convenience store meal? So I'm going to say, is eating convenience store meal. I don't like that hugely, but at least it implies, if it's true, we know what they're doing. That they're going to eat a convenience store. Is choosing convenience store meal. That's better. Man, that's better. Okay, I know you may find it strange that I get excited about names, but names are important. Names sink or let you sink or not your project sometime, because it just becomes hard to understand. Dylan and I, in our years as software engineers, we've seen some good names and we've seen a certain number of bad names. And being burnt teaches you lessons. You should try to choose your names. Choose your names well. So, is choosing convenience store meal? It's not perfect, but it's better than what we had there before. Okay, so if that's true, what do I do? If I've chosen a convenience store meal with this probability, it will return true if I eat a convenience store meal. So what do I do? Well, if that's the case, I will eat it. Boom. Drag it into this. Okay? And
What was that thing you dragged on?
I dragged in a thing called code. Okay? And for this, ladies and gentlemen, the code here will be very simple. The code here will be count. Well, what does it need to change? So I'll give you a hint, okay? So the label here will be eat a convenience store meal. Boom. And I'll make it nice and broad. Eat a convenience store meal. And the code, the name of this will be, eat chosen convenience store meal, because we actually chose it here. We elected to eat it. We had a healthy meal, and we had the corn dog. You don't have corn dogs here, and I think you're lucky. So you had that. You had that, spinach and broccoli. It's good meal, and there was the corn dog staring at you, or there was that pie with cheese-filled pie, and lard and cheese, and you opted for the lard and cheese. Okay, so what needs to happen here? How does our state need to change? What needs to change?
Counts.
The counts. Count convenience store meals remaining needs to be decreased by 1. Count convenience store meals remaining equals count convenience store meals remaining minus 1. Now, currently I'm experiencing a civil war internally, and I have 2 different voices in my head, each talking at high volumes. So this is the logic. But yesterday, upon this big screen, I showed you something that was quite similar. Does anyone remember what it was? Yeah, I showed you a plus plus, and there's a way we can write this, which is fairly transparent once you know it. It's sweet, and it's not NP complete. Well, no, never mind about that part. But it's sweet. It means decrease it by 1, minus. Now you don't have to do this. You can put in this equals this minus 1 if you prefer. It's just when you get into that this equals this minus 1, it's kind of verbose, and you got to kind of look. Okay, the thing on the right, is it the same as the thing on the left, to recognize? Oh, it's just decreasing it by 1. Here it's a little bit clearer. And as I say, if you look through my example models, you'll sometimes come across this. Even Dylan has been known to use this. from time to time.
The shorthand?
Yes.
Oh, I always use the shorthand.
Indeed, indeed, and I have to confess to the same. Yeah,
Minus equal 1, plus equal 1, and equals.
yeah, yeah.
Lots of fun little shortcuts.
Indeed. But are you folks okay with this? Will you forgive me this? If you're going to, I mean, the secret truth of the matter is if you're going to engage seriously with any logic, you're going to want to be comfortable with this. And just, I know it's just a factoid, you have to remember this means decrease it by 1. But that's really a nice thing to just know. This means decrease it by 1. Plus plus means increase it by 1. That's all you need to know. It's not that hard to remember, and it makes it clear what's going on. We're decreasing it by 1. Boom. Okay. Okay, so I will copy this into there, and I will replace that. So I always feel guilty getting you to learn jargon, but you know, when I first was going into health 15 to 20 years ago, really immersing myself, I did have to learn occasionally some jargon. Maybe more than occasionally. And so, you know, I don't, the guilt is not overwhelming. Okay, let's get to know each other, okay? Okay, ladies and gentlemen, that was that. And how about the other way? What does that do? What do we have to do here?
Supermarket.
Yeah, we're going to choose a supermarket meal. So you can tell me, perhaps even in a terse way, what this does. Well, let's use similar naming to this. This is called Eat Chosen Supermarket Meal. That's what it'll be called. Eat Chosen Supermarket Meal. Supermarket meal. And the label of this will be just eat a supermarket meal. Eat a supermarket meal. Market meal. Labels you can have repeats of. There'll be some others saying eat a supermarket meal. That's fine. But you can't reuse the name here. The name has to be unique. Dylan, I have a question for you. Do you know what this gets turned into beneath the covers?
Yeah, locally scaled
Okay,
things.
okay, okay.
Basically, for action charts, I never actually change the name. What I do though is I make a very descriptive label, because essentially, you know, the name of the component and the label of the component are really doing similar things. So I always find it, I don't ever see a point in duplicating what I've just done.
Yeah.
So I tend to choose the label over the name of those circumstances.
Fair enough, fair enough. Okay, and what will the code be here? Anyone want to say? Bearing in mind that we have a count of supermarket meals remaining up here, what will the code here be? What would that code be? What will it need to involve? If we consume a supermarket meal, what needs to change?
The
count of supermarket meals.
Exactly, count super, okay, and what would I put?
Minus one.
Oh, beautiful. Beautiful, thank you. Thank you, thank you. Okay, I just saved it, and, okay, so you don't hate me after all. Okay, that's reassuring, at least not all of you. So minus, that's good. Okay, great, thank you. So, yeah. Yeah. Sometimes I wish, as a computer scientist, been dealing so extensively with health scientists for the past 15 to 20 years, I sometimes forget what it's like to sort of recess to the point where I don't know, I don't remember what this means and so on, and it's hard, and so I don't know how terrible an offense it is, and I'm relieved that it's not making people run out of the room, at least. Okay, yeah, okay. So, ladies and gentlemen, we're done with those components. Now, over here, ladies and gentlemen, we're going to put in place some components here. So the first question is, do we have both remaining? And the answer was no. If the answer was yes, we chose between them. If the answer is no, then we only have one. We've got to figure out which of them we have. Does that make sense? Okay, so ladies and gentlemen, or maybe we have neither. That's a possibility, isn't it? Our larder is empty. Our cupboards are bare. Right? Okay, we're going to drag this in here. And what we're going to ask here is, okay, the name will be is only convenience store meal available. And you may wish to avoid this. I mean, as Dylan said, I mean, it's a matter of aesthetics whether you fill this in. Just from a point of view of hygiene, I feel a little bit better having things nicely named. Okay, and the label here is going to be something like, do we only have convenience, have a convenience store meal? Question mark. Okay, boom. If we only have a convenience store meal remaining, what are we going to do? Eat it. That's right. Yeah, we're going to eat it. That's exactly right. So, so we've just dragged in code for the true block, and the name here you may not want to sweat, but I will eat convenience store meal without option. Well, I'll just say eat convenience store meal. That's fine. And the label will be eat the convenience store meal. Okay. Okay. Mind you, there may be more than one. And what do we have to do? What's the code associated with this? We've seen it before. Yeah. Count. Is it count supermarket or count grocery? Sorry, count supermarket or count convenience? Count convenience store remaining minus. We're changed the state. By the way, this is an aspect of an action, right? We're undertaking an action. It's changing our state. This variable is keeping track of an aspect of our state, and there's rules governing it. These are the rules, right? We have these decision rules that are governing this. So this is another way that we capture actions, rules, and states, was with variables, these sort of flow charts, and within these flow charts, these decision points. Okay, eat the convenience store meal, great. Okay, if we only have a convenience store, if we don't have a convenience store meal, what do we need to check?
Do we have a supermarket?
Do we have a supermarket meal? Okay, so false. Okay, this next one will be this next one will be called is only supermarket meal available. This is a convention in Java. You use is to sort of say, to indicate a Boolean, is it true or false? Coming on, is only a supermarket meal available? And we'll have a nice label for it. Do we only have a supermarket meal available? Question mark. And we'll make it nice and big. Okay. So suppose we, and what is its condition? We didn't even set the condition here. We forgot to set the condition here, folks. What is the condition here for this guy? Did we only have a convenience store meal? What would the condition be? What does the condition involve? count,
Count supermarket.
okay, count convenience store meals greater than 0. Now we could say and count supermarket meals equals 0, but we know they're both not greater than 0. So if they're not both greater than 0, if we have only one greater than 0, then the other has to be 0. But you could say and count supermarket meals equals 0, equals zeros if you wanted to. Okay, you could say that the other one equals zeros. So I put for this count convenience store meals remaining greater than 0, and then how about for the supermarket one? Do we only have a supermarket one available? What would the thing be for that? What would the condition be for that? Count supermarket meals remaining greater than 0. Yeah. Okay. So, ladies and gentlemen, if we have only a supermarket meal remaining, what do we need to do? You said it before. Eat it. Okay, ladies and gentlemen. So we're going to have here the name be eat a supermarket meal, or eat supermarket meal. Maybe I should have said eat non-elective supermarket meal or something like that. The label will be eat a supermarket meal. Great. And what will the code be? Believe me, we're almost done with this. Count supermarket meals, what? Remaining. And then what? Minus. Thank you. Okay, great. Okay, eat a supermarket meal. And then what's the final situation? What's the final quality? The larder is empty, right? We have no meals available. Let's retrace the logic of this. I'm going to zoom in here. Do we have both meals available? If so, choose a meal according to our preference. We're done. If it's false, we know we don't have both available. Does that mean we only have a supermarket meal? If so, we eat it. If that's not the case, do we only have a supermarket meal available? If so, eat it. If neither of these are true, then it must be that we have no meals in our larder. And what do we need to do? We need to go shopping. So let's name this Go Shopping. And the label will be Go Shopping for a meal. Boom. Okay? Go shopping for a meal. And the code for this, ladies and gentlemen, will be the following. We're going to tell ourselves to go shopping. How are we going to tell ourselves to go shopping? How are we going to tell ourselves to go shopping? Where is it in the model that we go shopping? Where is it in the model that there's shopping logic? Wherein lies that? Wheretofore is that logic?
It's the food procurement.
It's this, remember? We needed to kind of go across this transition, right? Is that right? Okay. So, ladies and gentlemen, let's go up to this, and let's turn this transition into a message transition. This will be the only type of message in this model, so we don't have to worry about making it a conditional message. Okay? Okay. It's the only type of transition right now. Okay. Ladies and gentlemen, you're bearing with this. Who needs help from Dylan? Who needs help from Annie? Okay. And I trust it's not because you're beyond help. Okay. Okay. So, ladies and gentlemen, I would like you now. Okay, this is. Power that off and restart it. Okay, great. So let's go down once again, and let's go here. Go shopping for a meal, And we're going to do the following. We're going to send ourselves a message. Who's going to send our message? We are. We're going to send ourselves the message, go shopping. And to whom will we send it? To whom? To ourselves. How do we say ourselves? It begins with a T. Thank you. This. Send ourselves a message that says, hey, go shopping. Now that may seem strange, but the point is, you can think of it as telling the state chart over there to the right, hey, go, if you're in this state here, sorry, it's up here. If you're in this state, go shopping. If you're not seeking food now, go shopping. Okay?
If you hadn't put this, would that mean that any agent could send a message?
If we hadn't put this,
Yeah.
no, that would be implicit. It turns out that if you don't put something, it implicitly just does this.
Okay.
But now we could have put another agent here. We could have done, ask main, I don't know, random agent or something, random agent inside. We could send a message to someone else saying, go shopping. And that would lead to most interesting emergent behavior probably, but it wouldn't provide us with sustenance.
So if you left out this, it would be just send, go shopping, comma,
Yeah.
nothing.
Send, no. So it will be this, send, go shopping. We still have to tell it to whom to send it.
Okay.
We have to say, send it to myself. And that sounds strange, but again, the whole point is to get it to transition up here. Now, there's another way, there's another way we could do this. We could actually send, if it would be clearer to you, could actually send the state chart a message saying, deliver a message to this state chart. And that would also be possible. We could send our own state chart a message saying, hey, go shopping. Would you like to see that? Okay, so notice the name of this is Food Procurement State Chart. And we could say here, go shopping for a meal. We could say here, instead of this, we could say food, or if you want to be very specific about it, this dot food procurement. If we don't say it, it's going to do it. And it'll be deliver, oops. Is it sound, man? Okay, now I'm in a pickle. So there's I thought it was deliver message to or something. I'm going to have to do this. Okay.
So,
Yeah, receive message, that's it.
yeah. So with a lot of their message sending stuff,
Yep.
You specify the message and then the target afterwards. So there should be a method saying, send to state chart or deliver to. I can look it up.
This is it.
Yeah, but I mean, there's probably a more concise way to do it from the agent itself. So I'll take a look.
Oh yeah, that'd be sweet if you could find that. So here we're telling the state chart, receive a message, go shopping. That will also work.
And will that only send that message to the current agent within that stage?
Correct. That's why I'm saying I was extra pedantic. I don't have to say this, but it's my food procurement state chart that's going to receive this message. Is that helpful? Okay. Bit of plumbing there. I apologize for it. But who would like this up on the screen a little bit more? Would you like me to leave it up there? Are people okay with? Are you done with it? Are you done with it? Okay, ladies and gentlemen. Being done with this, we should be able to run this model. I think. Let's. Oh no, there's one more thing we have to do. Sorry, folks. One more thing that lies before us. One more thing that needs to be completed, and it's quite simple. When we're shopping in the supermarket, we need to do something. So I'm showing you shopping in the supermarket. Does anyone need that code from the send to the state chart? No? Okay. A little bit? You want it? Yep, you bet. There you go.
Is it replacing the send?
It's replacing the send. Yeah. This is just an alternative way to do it that makes it clear that I'm requesting that food procurement state chart to kind of handle this message. It has some conceptual clarity rather than just sending myself a message of whatever sort. But yeah, it's arguable which one's better. Yes, Colin.
And Nate, when you say myself, you're sort of taking on the person tab. Is that?
I'm pretending I'm a person.
You're pretending you're a person in that model.
That's right. Yeah, well spoken. Yes, I'm pretending I'm a person in the model, and I'm saying I'm sending myself a message. Computer scientists are a motley lot, and when we're teaching, we often enact or speak using we or myself. We'll sometimes place ourselves in a computational sort of context. We'll talk about where things live in the computer and so on. It's a little bit anthropomorphized, and this is one aspect, and I apologize for troubling you with that.
No, it makes sense, actually. It's easier to orientate yourself.
Okay. Well, glad it isn't off-putting. Okay. Are you ready with that? Okay. So, ladies and gentlemen, what's wrong with this? I say we have to fix two things, one here, one here. What's the shopping and supermarket? What does it have to do?
Have to add something to this counter.
We're shopping and we're going to need to replenish our larder, do we not? Yeah, okay. So let's go replenish our larder. So in the exit action, I'll go to the exit once you're done shopping. Count, what do you think I need to increase if I'm shopping in a supermarket? Count supermarket meals remaining. Okay, now I'm experiencing a civil war within myself. So I've got to decide whether to show you a longhand way to show something or so I'm going to do it like this. I'm going to say supermarket meals remaining equals this one plus 21. Okay, 21 being sort of, well, I'll make it very explicit. Let's make it quite explicit where I got that 21 from. That's kind of opaque. 3 times 7. It's 3 meals a day for 7 days. It's a week worth of meals. I can increment it like that. But it turns out we have a more concise way of saying that. And Dylan has been known to use this as well. So rather than writing this, you might alternatively write, you can write this. And I'm perfectly happy with this, and I think it's fully worthy. But it turns out you can also write this. And that connotes that I'm increasing this thing on the left by 3 times 7. Now, whether you want to do that is up to you. It has the advantage of brevity, but once again, you got to kind of know what this plus equals means. But basically, it means exactly this. It means that whatever this thing is, you set it to whatever it is plus 3 times 7. And there's a certain brevity to that I think of as admirable. It's parsimonious. Some might even say sparsimonious. Okay, so without prejudice, I'm going to put this in there, and you can choose to partake or not. Okay, so that's great. And then shopping and convenience store. What do we need to do there? Similar thing, except we'll probably get just fewer meals. Often with convenience store meals, you're just getting maybe 1 meal at a time. Tell me, Dylan, what do young people do?
At a convenience store?
Yeah.
I just go for 1 meal when I go.
Okay, so we're going to increment it by 1. How do we do that? In the strange language of computer scientists. Plus. Okay.
Could you also do plus equals 1?
You could indeed. You could indeed. You're cracking the code. I couldn't interest you in a Java development job, could I? So plus equals 1 you could do just as well, and it would be happy camper. Okay. Not even. Dylan, does Scala have plus?
Scala has a little bit of everything. It's got a bit of API bloats, but man,
I don't think, I think they may have jettisoned, there's some language that's a C like, well, they jettisoned plus plus, but they kept plus equals, so they just say do
Yeah,
plus
so
equals 1.
Scala has plus plus, and it usually means like concatenation of something.
Exactly,
So
yeah.
if anybody's wondering, we're talking about a different programming language that uses the same infrastructure as Java, and what they've done is they allow symbols to be used as function names, and you don't have to always use the dot or brackets. So you can actually define any kind of little symbol operation like that and do some really concise and crazy things, which is both wonderful and a curse at times, depending on who you're asking and what you're looking at.
So in any case, count convenience store meals remaining plus plus. We only get 1 meal. Are we okay with this? Okay. So, ladies and gentlemen, that I'd like to take stock. I just built. Who needs help from Dylan? Who needs help from Annie? They stand ready to serve you. Build and make sure your model doesn't complain. Make sure there's no errors reported. If you're done with that, I would propose that we run it and then we will take stock, because we're just about done with this example. In, I would note, record time. Okay, so I'd like to run it. Okay, yeah.
We have an eat meal event, and I'm not quite sure.
Oh, thank you. Thank you. Oh, thank you. Sure, I can't interest you in a job development job. Indeed. Okay. Yeah. Right. You're absolutely right, Chris. We still have to hitch this up. This eat meal event really isn't finished, is it? What we have to do here is we have to call this thing down here, eat meal. Okay? So we will say eat meal, and you just call it like this. It doesn't need any information to do its job. Now, mind you, if you were interested in having a similar thing, so in the eat meal event, we are having, remember this thing that goes off 3 times per day? We're just calling this eat meal thing that we created down here. Now, we could have asked that this thing needs information to do its job. Like maybe it needs some information on the person's age, and with children, their means of eating meals is different than with adults, or something like that. We could have had that. We could have specified that it needs the age of the person, in which case, when we call it, we need to provide an age. But right now, it doesn't require anything, so we're done, and we're off to the races. We're telling it, eat a meal. Boom. Are we ready with that? Okay, so I'd like you to build, and I'd like you, ladies and gentlemen, to run this model. And we should see some behavior going on, some food-seeking behavior. And I would argue that we probably want to elaborate this in one other way to show the fact that not all meals where someone of Dylan's age eats from a convenience store are driven by exhaustion of the larder. Okay, so people are circulating just as before. They're going zipping back and forth between their homes and these places. But now, ladies and gentlemen, the important difference is their zipping between these places is not occurring once a day purely. It's occurring when they need food. So let's go dive down, ladies and gentlemen, to a particular individual. So let's go up to this navigation menu and let us scroll down to the population. And here in the population, we will see information on a person. And you'll notice what's going on here. Do you see it? Do you see what lies before you? What's going on? What's going on here? This event is counting down to the next time it fires, and what's happening? What do you see these variables as doing?
Changing value.
They're changing values, they're decreasing, and then you notice when they decrease, watch this. Here, when you decrease here, it's going down, and then it is going to go engage in food seeking. Now, we're most of the way through this thing. We're calling this decision rule and having people go at food. You'll notice the count of convenience store meals is never incrementing much. That's because shortly after they're obtained, they are consumed, apparently. Okay. Now, one of my questions is, are they in fact shopping in convenience stores? Because I don't see this going up at all. I see it going down. I see them decreasing, and then it just gets really high again, and then down. Even though this is someone with quite there we are. Okay, there we are. They are eating their corn dogs. Okay. There we are. Yeah, they are eating them. Okay. So, ladies and gentlemen, we have people consuming these foods. But there's some important elements, ladies and gentlemen, that we've missed here. And these elements have to do with nature of the food environment. How far it is to a store. How far it is to a grocery store versus a convenience store. So could I put in, with your leave, could I put in some logic for that? Okay? Okay, great. Maybe what I'll do is just to sort of break this up into